Hi, okay, so here we are at section 1.1 of the study guide. And this is introducing the idea of function, which is something you're probably kind of familiar with, and I'll try to explain that. It's not horribly scary, hopefully. It's just a nice mathematical word for it. I don't know if you ever remember playing Guess My Rule in school, but that's the main idea of a function is, if you put 7 into a machine and 14 comes out, and 2 in and 4 comes out, 5 in, 10 comes out. If you put 1 in, what do you expect to come out? Or what would you expect to put in to get 6 out? And what would you put in to get a 7 out? That machine there is a function. So that's what we're going to be looking at in this section. So a function is a relationship between two quantities, which we usually call variables, where the first variable determines the second. So the cost of a car is a function of the year it was made, meaning the cost of the car depends on the year the car was made. Newer cars are more expensive. As you get older, they become less expensive, although if you go far enough back, then they become classic and they get more expensive again, usually. Also depends on the condition and some other things. But here we're just looking at a relationship between the cost and the year it was made. And in general, you could find a relationship between those, and that relationship is called a function. Or the temperature outside is a function of the time of the day. As we get closer to the middle of the day, it warms up, and at night it cools off. So once again, these aren't perfect because you can have cold fronts come through and all sorts of other things. But in general, you can create a relationship between the temperature outside and the time of the day. The price of fuel is a function of the world oil price. That's usually much closer, but also not perfect because it also depends on transportation costs and all sorts of things. But that's one where you can actually imagine that, somebody could sit in an office and write down a formula for what that is, and that would hold pretty true. The temperature in Celsius is a function of the temperature in Fahrenheit. So that's something that we have a formula for, exactly relating how does the temperature in Celsius relate to the temperature in Fahrenheit. Probably could tell from my accent, I'm American, and so when I first moved here, I was constantly having to convert from a Celsius to Fahrenheit because I hadn't learned to think in Celsius yet, and there's a formula that exactly tells us how to do that. So, and all those kind of things where you have formulas for them, or things where there's a relationship, even if we don't quite have a formula, those are called functional relationships, and that's what we're going to be looking at. So a function is a relationship between two quantities. So for instance, y equals 5 minus 2x. So x is, let me pick that. So x is one of my variables, and y depends on x. So I put in a value for x, and I get a value out for y. We sometimes write it in this notation, f of x. That's what we call our function notation. And that's one of the things that might be something new to you. Here we have f of x equals the square root of x plus 4. So whatever x I put in, I add 4 to it, and then I square root it, and that will give me my f of x value, which is my y value, my output. So as I've been saying, f bracket x is read f of x, and it's a function of x. It definitely doesn't mean times, so you got to be careful with the different meanings there. Got to associate it, in context. So when I have f bracket x, that means f is a function of x. That's the variable it's a function of. F is the name of the function, x is the input variable, and f of x is the output variable. And sometimes we just replace f of x with y in order to emphasize that every y value depends on the x value. So you can use either y or f of x, as we did in the first line up there. And of course in the graph, when I think of the graph, if that's the x, and you normally think of that as the y, if you've written it as f of x, you can also think of that as the f of x axis. So here's an equation, a function, f of x equals x cubed minus 5x squared minus 22x. And I've also given you its graph. So it's this nice curve. And my question for you is, what is f of 6? So what the notation means when I have the 6 following, the 6 is there in place of the x, and it's a function of x. So what that says is you replace every x up here, all 3 of them, well, 4 if you count that in the of x part, but all 3 in the right-hand side of that equation, you replace all of those with 6. So you get 6 cubed minus 5 times 6 squared minus 22 times 6. And when you put all that in, you get minus 96. Of course, because we had the graph and I actually had a point on the graph over here, we actually could have looked at that. And a graph is the set of all the points put together, and it actually points out that the point is 6, negative 96. One of the big things that we look at with function is what's the domain of the function. And the domain are just all the values you can substitute in. So if we think about the guess my rule game at the beginning slide, it's all the things that can be inputs, so that if I put it in, it'll have an output. Because sometimes you'll put something in and the function will go, I don't know what to do with this. And so the idea is, what are the things we can put into the function? And for functions, when there's things you can't put it in, we should probably state them, but in mathematics we usually don't. We assume that you'll figure it out. Although you will notice we do try to be careful about that usually, and lots of your assignment sheets and stuff will have things on it where we're noting what the domain of the function is. But sometimes, especially at the beginning, we'll ask you to figure it out. So how are you going to work out the domain? You need to think first about the restrictions. What are the things you can't put into the function? So look at these 4 functions here. Y equals 5 minus 2x. Is there anything I cannot put into it? So, I mean, you might try out some values. Try putting in 0. Try putting in 10. Try putting in negative 10. Is there any number that you would put in there and you wouldn't know how to calculate it? Hopefully your answer is no. You can calculate with everything there. And so that tells us that the answer there is going to be all real numbers. And we're only looking at real numbers. We only want to get real numbers out. So if you've ever studied complex numbers or anything else, we're not considering that in this course at all. We're only interested in real numbers. So what about square roots? Do we run into any problems with square roots? You're taking square root of 4 minus x. Try substituting it in different values for x there. Put in 0 for x, 10, negative 10. Is there anything that runs you into problems? Hopefully your answer is yes. We'll come back to that one. And do the same now with these last 2. Go ahead and pause the video. Think about those. Try putting some different values in and see what are the values that cause problems. And those are the ones we want to concentrate on. Okay, so here's my answers and how you should write them out. So for that first problem, sorry these aren't quite lined up. For that first one, we said the answer was all real numbers. So we can say that's everything from negative infinity to positive infinity. Infinity is not really a number, it's an idea, so we always put rounded brackets there. So that's the interval negative infinity to positive infinity. But for the square root of 4 minus x, when you plug different numbers in, hopefully you did find there was a problem. So like when you substituted 10 in, you get 4 minus 10, and then you're getting the square root of negative 6. So what we have to make sure is that 4 minus x has to be bigger than or equal to 0. Adding the x over to each side, you get that 4 is bigger than or equal to x. And maybe a better way to write that is x is less than or equal to 4. So x is less than or equal to 4. A better way to write that is in interval notation, is it's all the numbers from negative infinity all the way up to 4. And here, because of the equal to 4, we're including 4, so it's a square bracket. If it was just strictly less than 4, we wouldn't include 4. But 0, square root of 0 is fine, that's 0. So you want to include 4. For this next one, the fraction, our problem with fractions is we can't divide by 0. So the problem is if the denominator is 0. So what we know is that x minus 7 can't be 0, or that x cannot equal 7. If we want to write that in interval notation, we're basically saying it's every real number except for 7. So it's everything from negative infinity up to 7, but not including 7. So rounded at 7. Then you're starting immediately after 7. We can't start at 8 because there's lots of numbers between 7 and 8, like 7.01 and 7.0001. It's anything just to the right of 7. So we put a rounded bracket in 7 and go all the way to infinity. In this last one, we've combined together square roots and fractions. So what's underneath that square root has to be bigger than 0, right? Because if it's equal to 0, I'll have the square root of 0, and then I would have I'd be dividing by 0. So I need s minus 9 to be strictly bigger than 0 in this case. Okay, so solving that, adding 9 to both sides, I get s is bigger than 9. So that's starting at 9, going all the way to infinity. We're not including 9, so it's rounded bracket at 9. To summarize all that, if there's no restrictions on your domain, then your domain is all real numbers, which we write as the interval from negative infinity to infinity. If you're dealing with square roots, then what's underneath the square root can't be negative, so it has to be bigger than or equal to 0, and you need to solve that equation. In this example, it became x had to be less than or equal to 4, so negative infinity to 4. Square brackets mean we include 4. If you need more information on this interval notation, go back to chapter 0. There was a section on interval notation. Fractions, we left out 7, so you're just leaving out one thing from that whole entire interval of all real numbers. So it's everything up to 7 and everything after 7. So you're just rounding it at 7 on both sides there. And if you combine fractions, square roots, just thinking about the fact that here it can't be 0 and it can't be negative under the square root. Also need to be thinking about domains as you learn our new functions, as we go into logs and trig functions. There's going to be special domains for those, so you'll want to pay attention to those and think, how would you write the answers out? Okay. So here's an example. If f of x equals x squared minus 4 divided by x minus 2, and g of x equals x plus 2, then we can say the functions f and g are equal. Is that true? And the main thing I want you to think about here is domain. So once again, pause the video, see what you think. The answer is false. So why is the answer false? Because if we think about the domain, if we look at f of x, it can actually be simplified because x squared minus 4 factorizes as x minus 2 times x plus 2. So if you don't see that, that's the difference of squares. You can expand that out and check that you get x squared minus 2x plus 2x, so the middle terms go away, minus 4. And you're dividing by x minus 2, so it has an x minus 2 in the top and bottom. And so, in a sense, we can cancel those, and you do end up with just x plus 2, which is what g of x was. But that only is true if x does not equal 2, because we have to remember, back in this original function, it does have that restriction that x can't equal 2, because that would give us 0 in the denominator. So they're almost the same function, except that g of x has a domain of all real numbers, and f of x can be any real number except for 2. So they're not equal at that point. But not least, maths is not a spectator sport, so make sure you're getting out there working problems, working in your understanding of function.